Hello, Jerry. I'm gonna make you this video that you wanted. I'm gonna explain everything from logic gates all the way to CPUs. For this video, I'll be explaining how logic gates are the building blocks of digital circuits. They're tiny electronic switches that follow rules from Boolean logic. They boil down specifically on letting the user know what is true and what is false. For example, each gate can be represented by a simple box. You probably know this from your pre-calc courses. And you know for every function, you have an input and you have an output. Following the same principle from algebra, we can start explaining the logic gates. For example, we can talk about the AND gate. An AND gate is represented with the following symbol. It has two inputs. It usually has more, but for the simplicity of this tutorial, I'm gonna explain two inputs and one output. And the following table is called a truth table. It gives properties of that gate. So 0, 0, 0, 1, 1, 0, 1, 1. And over here, I have an output. So for the AND gate, you're always gonna have an output if both inputs are 1. Only. Only and only if both inputs are 1. So I have an output here. And for the rest, I have a 0. This is very similar that if you have a power source and you have a wire and you have a switch and you have another switch and then you have here a resistor, and we can say this is the output. As you can see, current always need a full circuit to complete the circuit. However, if those switches are broken, then no current can go through. However, if you close one, you can still go through. It's not only until you close both switches down that you have a full circuit. And it's at this point where the current flows all the way. That is represented as an AND gate. There's also something called an OR gate. An OR gate is represented with the following symbol. The truth table for an OR gate is usually represented like this. So the idea of an OR gate is you will have an output if either of the inputs are ones. So if either ones is 1, then you have an output. If both switches are off, then you have a 0. Taking the same analogy of the top circuit, this can be represented the following way. As you can see, current has two paths. It can go this way or it can go this way. It has two paths to complete the circuit. So it can go through the top or it can go through the bottom. Or it can go through both, like in this is the case for this. Another type of gate that we have is called the NOT gate. A NOT gate is the inverter gate. The inverter gate is represented with the following symbol. So any input that you have here is going to get inverted. If you have a 0, you have a 1. If you have a 1, you have a 0. Another type of gate that we have is called the NAND gate. It's just a NOT AND gate. It's similar to the AND gate, but inverted. So if you have this type of gate, remember the AND gate, it was 0, 0, 0, 1. This is going to be 1, 1, and 0. So if you have a 0, it's always going to be a 1. If you have a 1, if both of them are 1, it's going to be off. That's the opposite of an AND gate. And then you had a NOR gate. A NOR gate is also represented with the following symbol. And the truth table for that gate is 0, 0, 0, 1, 1, 0, 1, 1. And that one is represented this way. So you only have a 1 if both outputs are off. Finally, another gate that we have is called the XOR gate. The XOR gate is represented with the following symbol. And this is the truth table. So every time and the inputs are different, you have an output that is on. If both inputs are the same, the input is off. That being said, we also have an XNOR gate. And this one is represented with the following symbol. It is basically an XOR gate, but inverted. So exclusive NOT OR gate. So for that one, the following truth table applies. So every time you have same input, you have an output. If the inputs are different, the gate is off. Every operation a CPU performs, from adding numbers to making decisions, is built from the combination of these gates. Learning logic gates is the first step of understanding how computers think. So this is your video. I hope you liked it. If you enjoy it, subscribe.